test, you will have sufficient time for the test. So need not to worry about the test timing. Each and everything will be shared after the end of the session. Okay. So our esteemed speaker. Hello.
हाँ सर, एक्चुअली क्या है, अटल पोर्टल पर जब अटेंडेंस भर रहे हैं ना, तो वहां पर टाइटल एनर्जी सस्टेनेबिलिटी एंड क्लाइमेट चेंज शो कर रहा है।
आई डोंट नो ऐसा कैसे है, तो ये
आप देखिए
टाइटल
सर,
तो हमारा
वहां पर मेरी अटेंडेंस भी दिख रही है, मैंने अपना असाइनमेंट, मैंने अपना फीडबैक सबमिट कर दिया है, लेकिन जो टाइटल टॉपिक है वो एनर्जी सस्टेनेबिलिटी एंड क्लाइमेट चेंज शो कर रहा है।
कोई दिक्कत नहीं है, आपने फीडबैक सबमिट किया है, तो आप जो स्पीकर्स अभी यहाँ पे इतने दिन से सुनते आ रहे, उन्हीं स्पीकर्स का नाम आया ना?
हाँ, उन्हीं का नाम आया, उन्हीं का नाम आया।
हाँ हाँ, सो नीड नॉट टू वरी, उसका कोई इशू नहीं है। ठीक है,
ठीक ठीक।
ओके। सो अभी जो है सभी लोग इसको ज्वाइन कीजिए, और ये लास्ट सेशन है और बहुत ही शानदार स्पीकर हैं, तो तभी आप पहले आज के सेशन को अच्छे से सुनिए। ठीक है, सो आई वेलकम यू ऑल. Good evening, and I welcome you all, to all the participants and our esteemed speaker, Dr. Tikendra Nath Verma. It is my proud privilege to introduce Dr. Tikendra Nath Verma. Dr. Verma was born at Bhilai, Chhattisgarh in India. He has received his Bachelor of Engineering degree in Mechanical Engineering with securing first division from Pandit Ravi Shankar Shukla University, Raipur in 2006. After his graduation, he did his master's degree in Thermal Engineering in 2009 from Department of Mechanical Engineering, Maulana Azad National Institute of Technology, Bhopal. He has obtained his PhD degree from National Institute of Technology, Raulkela, from Raipur. He joined Institute of Technology, Korba, as assistant professor in July 13 to September 2015. Later on, he joined National Institute of Technology, Manipur, as assistant professor, and there he worked from September 2015 to May 2020. After that, he has joined Mechanical Engineering Department in Maulana Azad National Institute of Technology, Bhopal, as assistant professor in June 2020. And presently, Dr. Verma is working as an associate professor in Maulana Azad National Institute of Technology, Bhopal. He has 3 ongoing projects from different funding agencies like Department of Science and Technology, DST Manipur, Seed Grant, etc. He has published more than 250 research articles in SCI and Scopus Index journals, and also presented 52 conferences, 52 papers, reputed conferences, written 21 book chapter, 3 books with high impact factor journals. His present citation is more than 6,500 with H index 48, I10 index 109. He has successfully guided 7 PhD candidates and 22 MTech candidates. He has organized program as a convener, organizing secretary for different faculty development program, workshop, seminar, etc. He has 6 patents granted and filed 6 patents in India and Australia. He also serves as a guest editor and associate editor for different reputed journals like Environmental Science and Pollution Research, Materials Today Proceeding, Lecture Notes in Mechanical Engineering. He is also editor of Elsewhere book with the title Vegetable Oil Volume 1, Biofuel Technology, and Volume 2, Future of Different Seed Oil. Recently, Dr. Verma has been featured in top 2% scientists of the world from India in all fields by a survey conducted by Stanford University. He is an active member of Institute of Engineers, Fluid Mechanics and Fluid Power, Indian Society of Heat and Mass Transfer. He has also organized 4 Karyasala high-end workshops under Department of Science and Technology SERB scheme with each rupees 5 lakh. He also serves as potential reviewer of reputed journals like Energy, Energy Conversion and Management, Applied Energy, Fuel, Journal of Cleaner Production, Journal of Building Engineering, Waste Management, Journal of Hazardous Material, International Journal of Ambient Energy, Journal of Thermoanalysis and Calorimetry, Biomass Conversion and Biorefinery, etc. Apart from his academics and research, Dr. Verma has played and won Indo-Nepal International Tennis Ball Cricket Match Series in 2016-17, played 5 times National Tennis Ball Cricket Championship in year 2011, 12, 15, 16 and 17. 3 times awarded Khel Shikhar Swarn Alankar by Chhattisgarh government in 2011, 2012 and 2015. So I again welcome you, Dr. Verma, and also I am also thankful that you have accepted our invitation to deliver talk faculty development program. Thank you, sir.
Thank you, Sharma sir. Just a second. So, sir, PPT is visible?
Yes, sir, it is visible.
Okay. Thank you, sir, for this introduction. Today, we have discussed two topics, this introduction to different generation of biofuels. In this, I'll discuss the basic of biofuels, the different generation, first generation, second, third, and last, fourth one. Then we can discuss some emission norms also. Then I'll present some slides related to my research work, in which I have used microalgae. Two slides for the different parameters like performance, combustion, and emission parameter. And last is conclusion. So before starting this presentation, there are some content like introduction and sources of energy, depletion of natural reserves, need of alternate fuels, major challenges what we are facing when we are doing this, when we are using these biofuels, biodiesels, then emission and emission norms, BS5, BS6, like that. Then different generations and types, current trends of biofuel research, what are the different testings and methods which we are using when we prepare or when we produce the biodiesel, like FTIR, GCMS, and etc. And then last is our results and discussions. So in
sir,
this,
आपका न्यूज का कंटेंट हम भेज दिए हैं सर. बस अच्छा सर, हम देखते हैं. अगर फोटो मेरे पास यही था और स्टूडेंट लोग से अभी फोटो मिला नहीं है.
1 second. Dr. Murli, your voice is audible. Kindly mute.
Okay, so in the introduction, as we know, the increase in energy consumption, particularly in the past several decades, has raised fears of an exhausting vital natural resources. So the main reason behind that, rapid industrialization and massive growth in population has increased the dependence and the use of natural fuels. So approximately 90% of our energy requirements are made by the fossil fuels only. So the past studies suggest that if we exploit at the same rate, the coal reserves will deplete in the next 200 to 300 years, and petroleum deposits will deplete in the next few decades. So it is important for us to engage in research and development of alternative fuels so that we may not face scarcity of natural resources in the future. So India is 6th rank in terms of energy demands, but its domestic crude oil satisfies only 1/4 of our current demands. So greenhouse gas emission and global warming is also the forefront of this critical issue. So India is currently facing energy crisis with its major dependency on coal, crude oil imports to meet sharply growing energy needs of the country. More than 40 or 45% household lacks access to electricity also. So what are the causes, or in which area see energy crisis in India? So demand is more than supply, and this is the main cause of present power crisis. During the 5-year plans, stresses were given on the development of industries, but to cope up with the industrial development, equal stress was not given on the development of power. Most of the power stations of India are of thermal origin. So we know that this one, there are basically two types of energy. The first one is our non-renewable energy source, and the second one is our renewable energy sources. In the non-renewable, the example is our oil, coal, natural gas, nuclear energy. Then renewable energy sources like solar, wind, hydro, biomass, and geothermal, and others also. So in this, you can see the advantages and disadvantages of this renewable and non-renewable energy sources. We know that the coin has two sides, head and tail. Similarly, for each and everything, there are some advantages and some disadvantages also. So this slide shows the simple advantages and disadvantages of renewable and non-renewable energy sources. So fossil fuels we are talking. So these are the hydrocarbons. Fuels are our natural gas formed from the remains of dead plants and animals. In common dialogue, we can say the terms fossil fuel also includes hydrocarbon containing natural resources that are not derived from animal or plant sources. So fossil fuel is a general term for buried combustible geological deposits of organic materials formed from decayed plants and animals that have been converted to crude oil. Then coal, natural gas, or heavy oils by exposure to heat and pressure in the earth crust over hundreds of millions of years. So renewable energy uses energy sources that are continually replenished by nature, the sun, wind, and water, earth, heat, and plants. And renewable energy technologies turns these fuels into usable forms of energy, most often electricity, but also heat, chemicals, or mechanical power. So why we use this renewable energy? Today, we primarily use fossil fuels to heat and power our homes and fuels for our car. It's convenient to use coal, oil, natural gas for meeting our energy needs, but we have a limited supply of these fuels on the earth. So we are using them much more rapidly than they are being created. So eventually they will run out. And because of safety concern and waste disposal problems, the nation's energy needs are expected to grow around 33% during the next coming 20 years. So this renewable energy can help fill this gap. Even we had an unlimited supply of fossil fuel, using energy, renewable energy, we can say it is better option for the environment also. So this renewable energy technologies, we can say clean energy or green energy also, because they produce very few, or if there is any pollutants also. So burning of this fossil fuels sends greenhouse gas into the atmosphere, trapping the sun's heat and contribute to global warming also. So climate scientists generally agree that the Earth average temperature has risen in the past century. If this trend continues, so in the results will be the sea level will rise, then the flood, heat waves, drought, and other extreme weather conditions could occur more often. So other pollutants are released into the air, soil, and water when fossil fuels are burned. So these pollutants take a dramatic toll on the environment and on humans also. Air pollution contributes to disease like asthma, then acid rain from sulfur dioxide and nitrogen oxide. Then nitrogen oxides also contribute to smog also. So what is the need of this alternative fuel? Why we are going to this side of area, or we can say renewable energy? So as we know, there are fast depletion of fossil fuel, reduction of pollution caused by fossil fuel, protection against global warming, increase in economy of the nation through omission in important, local production of alternate fuel, then meeting the demands in the global energy. And the last, India at present imports 3/4 of the total energy demands from the other country. So there are different types of biofuels like biofuels, alcohol, hydrogen, natural gas. We can discuss this one by one thoroughly. So before going this, the people are somehow doubts like what is the difference between bioenergy, biopower, or biofuels. So we can say bioenergy is the energy derived from biomass such as plants. If we have ever burned wood in a fireplace or campfire, we have used bioenergy, but we don't get all of our biomass resources directly from trees or other plants. Many industries, such as those involved in construction or the processing of agriculture products, can create large quantities of unused or residual biomass, which can serve as the bioenergy sources. Then there is a biopower. So after hydropower, which is related to water, biomass is this country's second leading resource of renewable energy, accounting for more than 7,000 megawatt of installed capacity. Some utilizing and power generating companies with coal power plants have found that replacing some coal with biomass, and it is a low cost option to reduce undesirable emissions. As much as 15% of the coal may be replaced with biomass. So biomass has less sulfur than coal, therefore less sulfur dioxide, which contribute to acid rain, and it is released into the air. Additionally, this biomass in this boiler reduces nitrogen oxide emissions, and this process is called gasification. The conversion of this biomass into gas, which is burned into the gas turbine, we can say it is another way to generate electricity. So the decay of biomass in landfills also produce gas, mostly methane, which can be burned in a boiler to produce steam for electricity, and we can generate, or industrial process we can use. So biomass can also be heated in the absence of oxygen to chemically convert into a type of fuel oil called pyrolysis oil, and it can be used for power generation and as a feedstock or fuels and chemical production also. Then if you talk about biofuels, so it can be converted directly into liquid fuel. That is called biofuels. Because biofuels are easy to transport and possesses high energy density, they are favored to fuel vehicle and sometimes stationary power generation. The most common biofuel is ethanol, an alcohol made from the fermentation of biomass high in carbohydrates. The current largest source of ethanol is corn. Some cities uses ethanol as a gasoline additive to help meet our air quality standard for ozone. Suppose flex fuel vehicles, which is now in the market also, or which can use a mixture of gasoline and ethanol, such as E85. We know that very well, a mixture of 85% of ethanol and 15% of our gasoline. So another biofuel is biodiesel, which can be made from vegetable and animal fats. Biodiesel can be used to fuel as a vehicle or a fuel additive to reduce emissions also. So corn ethanol and biodiesel provide about 0.4% of the total liquid fuel market. To increase our available supply of biofuel, researchers are testing crop residuals such as corn stalks and leaves, wood chips, food waste, grass, and even trash of potential biofuel research. So what are the different major challenges before going to this area? So best of our knowledge, there are three major challenges which must be taken into consideration for developing alternate fuel. The first one is our climate change. The second one is depletion of fossil fuel. And the third one is our air pollution. So there are three major challenges which we have to face before using this alternate fuel. So in climate change, emission of CO2 is highest in the present decade. The temperature is expected to increase by 2 degrees Celsius in the next few decades also. Then second one is depletion of fossil fuels. Almost 97% of all road transportation uses conventional fuel, and this is expected to deplete after few decades. And the last, air pollution. So in air pollution, it increases in vehicular exhaust and rapid development of nation increases the risk of air pollution to the living beings. So another why we are using this alternate fuel, there are several major environmental problems like global warming, then acid rains, air pollution, oil spills, then health threat to fossil fuel when we are using this. There are some major environmental problems. If you talk about global warming, so it is also known as very well-known greenhouse gas effect, and it is caused by an accumulation of carbon dioxide, CO2 emissions that do not leave the Earth's lower atmosphere. And this carbon dioxide is the gas responsible for keeping the Earth climate warm, because it absorbs radiation that would be the important part of greenhouse effect. Otherwise, this leaves the Earth atmosphere and disperses into the upper atmosphere. So CO2 is moderate amounts. It is necessary in order to maintain a certain temperature that supports life on Earth. However, an excess amount of CO2 in the Earth's atmosphere is building up due to this fossil fuel emissions that contains large quantities of CO2. So this CO2 has formed a thick blanket that traps heat near the Earth's surfaces. So fossil fuels are the largest producer of CO2 emission, and the significant use of fossil fuel is thickening the CO2 blanket over the Earth. So this blanket traps UV rays, ultraviolet rays, which are essentially heat that have been originally received by the Earth from the sun. So the natural process of heating and cooling of the Earth's surface, this UV rays coming from the sun heat the Earth's surface and warm the Earth. So these UV rays, after hitting the Earth's surface, should be bounced back up into the atmosphere. So this greenhouse gas effect, the unnatural, we can say, unnatural accumulation of CO2 in the lower atmosphere is forming a thick blanket that is preventing the second part of the natural process, this UV rays leaving the Earth's atmosphere from occurring, and the UV rays traveling from the sun are able to penetrate the CO2 blanket and arrive at the Earth's surface, but they are unable to penetrate the CO2 blanket after they are radiated back to the Earth surface. Therefore, they remain trapped near the Earth's surface. Then there is one more problem which I discussed, this oil spill. Oil spill is a major environmental disaster, and it occurs when an oil tanker transporting oil to shore from an ocean-based oil rig sinks and the oil cargo is released into the ocean. So this can also occur when oil rig located in the ocean accidentally it will leaks, or we can say exploit also. So it is also important to note that when oil spill occurs on water, it is extremely difficult to prevent the oil from spreading. It is also impossible to clean up an oil spill that occurs in water. So pollution to ocean is extensive, and countless fish, other valuable and beautiful forms of marine life and coastal lines are affected. So it may not appear to be a major threat to the environment because they normally occur in very remote areas. So the oil that is released into the ocean from an oil spill, it spreads very far and affects large area of ocean life. So eventually the oil reaches coastal land and destroy the animal and plant life that are part of the coastal ecosystem. So this oil is very toxic and poisonous substance. It is important to remember that oil is retrieved from the deep below the Earth's surface. It is not meant to be exposed directly to the environment, because human, animal and plants life and the natural functioning of the atmosphere are not adapted to deal with the chemical composition of fossil fuel. Another type of oil spill can occur when a land-based oil pipeline burst or leak. Unfortunately, oil spill occurs too frequently nowadays. Then there is an acid rain. So in the acid rain, there is an after effect of the use of oil and coal. When oil or coal is burned through combustion in an engine, the sulfur contained in the oil is released through the emissions of the combustion and produces gaseous sulfur dioxide. So the amount of oil and coal used each day around the world produces a large quantity of sulfur as a result of the fuel combustion takes place. Even though the sulfur content of fossil fuel is so slow, millions of tons of sulfurs are released into the air each and every year due to the heavy use of fossil fuel. So globally, we can say this sulfur dioxide emissions are about 100 million tons annually and are increasing due to sudden third world industrialization. So this acid rain occurs because of this sulfur dioxide and nitrogen oxide are released through fossil fuel combustion. Due to this, we can say due to complex chemical reaction that takes place in the atmosphere, sulfur dioxide is transformed into sulfuric acid and nitrogen oxide is transformed into nitric acid. These acids are found in rain clouds and disseminated back to Earth's surface through precipitation, like we can say rain and snow. Then this polluted precipitation in acid-rich and is collected in groundwater and released into rivers, lakes, and oceans. Not only those secondary pollution contaminate water on Earth, it also causes other harm to the environment, such as the destruction of valuable forests and contaminants, human grown crops, as well fisheries and other animal life that create their habitat near water system or affected because marine life cannot thrive in waters that are heavily acidic. Then air pollution. Air pollution can be defined as anything that causes a reduction in purity. So air pollution can be defined as the reduction in purity of the air. Most of the Earth's air pollution is caused directly as a result of emissions from fossil fuel. The process of combustion, which occurs when a fossil fuel runs through an engine and is burned in order to create energy or heat, you can say. So the combustion releases gases and minute particle which is found in fossil fuel, it will go into the air. So all life on Earth depends on air for the basic respiratory process. So like plants, animals, and humans all depends on the balanced amount of the gases like oxygen, water vapor, carbon dioxide as a basic our requirement of life. Since the gases and particles released from fossil fuel emissions are not naturally present in the air, they are not compatible with the basic respiratory process that our forms of life have developed over millions of years. So when foreign substances are introduced into the air, it is obvious that the natural balance of life on Earth will be affected as the respiration processes of all life on the planet are not adapted to these pollutant gases. So these gases releases from fossil fuel emissions that causes the greenhouse effect are also polluting the air. This carbon dioxide, nitrogen oxide, and methane, the three most prevalent greenhouse gases, are also responsible for lowering the quality of air that we breathe. This PM emission, we can say particulate matter, that this is not a greenhouse gas, and it is also an air pollutant released from fossil fuel emissions. Ozone is a gas that is created into the atmosphere by reaction between several of the gas released from fossil fuel emissions and is considered a pollutant because it is powerful irritant to the human respiratory system. Then there is a last one, health threat of fossil fuel use. This CO2 and nitrogen oxide are poisonous gas that are dangerous to human when we inhale. So these gases are produced mainly from mobile source emission, that is our vehicle exhaust emission, and this exposure can result in upper respiratory illness such as asthma and other diseases also. It increases rates of respiratory illness in urban centers, areas where fossil fuel exhaust emissions are highest. It has been documented for the past several years. So mainly the children's and the elderly are the most, we can say, susceptible to developing asthma and other respiratory illness as a result of exposure to fossil fuel emissions. So the cases of asthma and respiratory illness are increasing at alternatory rates among the entire population because of this increases in the concentration of carbon dioxide, nitrogen oxide, and particulate matter. So this PM is released in fossil fuel emissions alongside CO2 and nitrogen oxide. And this PM is of extreme concern to human health. So these are the major constraint, this performance, infrastructure, and cost when we are discussing biodiesel as a feasible fuel. So in the performance, we need the efficiency, the acceleration, top speed, CO2 emission, and we have concern about this air pollution also. Then infrastructure, the existing infrastructure we have to update. So there are a lot of investment required throughout the country. And the last one is the total cost of ownership and retained maintenance cost is also increased. Then there are 2 to 3 slides related to this emission and emission norms. So this first emission norms were introduced in the India in 1991 for the petrol fuel. And in the next year, very next year, this 1992 for the diesel vehicle. So the catalytic converter became mandatory for the petrol vehicle and unleaded petrol was introduced in the market. So this BSES, we can say Bharat Stage Emission Standards are emission standards instituted by the government of India to regulate the output of air pollutants from CI engine and SI engine, compression ignition engine and spark ignition engine equipments, including motor vehicles. So with appropriate fuel and technology, they limit the release of air pollutants such as nitrogen oxide, carbon monoxide, hydrocarbon, particulate matter, sulfur dioxide from a vehicle using IC engine. So as the stage goes up, the control on emission become stricter. So we have started in BS1 in 1991 for the petrol and in 1992 for the diesel, but now we are in BS6. So in the last 30 years, we have achieved up to BS6. So what are the difference between this Euro norms and BS norms? So Euro norms is European country, they are adopted this emission norms, and BS we have just copied and pasted from that that they are using the norms. So this BS norms have been styled to suit specific needs and demands for our Indian conditions, or we can say Indian road conditions. The differences lie essentially in environmental and geographical needs, even though the emission standards are exactly the same. For instance, Euro 3, if you talk about Euro 3 is tested at sub-zero temperature in European country. In India, where the average annual temperature ranges between 24 to 28 degrees Celsius. So another major difference or distinction is in the maximum speed at which the vehicle is tested. So a speed of 90 km/h is stimulated for BS3, whereas it is 120 km/h for Euro 3, keeping other emission limits the same in both the cases. In addition to limits, we can say the next one is our test procedure has certain final points too. For instance, the mass emission test measurement done in gram per kilometer on the chassis dynamometer, it requires a loading of 100 kg weight in the addition to unloaded car weight in Europe. But in India, BS3 norms requires an extra loading of 150 kilogram weight to achieve the desired inertia weight, mainly due to our road conditions. So these are some engine pollutants which I have already discussed, this hydrocarbon, carbon dioxide. I have taken this one of my paper, carbon monoxide, oxides of nitrogen. This particulate matter in the combustion process of different hydrocarbons, solid particles like acetylene are formed through dehydrogenation, polymerization, and agglomeration, etc. So these are the years of nationwide implementation. You can see in Euro 1, then Euro 2. Now we are in BS6 2020. I have taken this one from one of my paper, which is published in Energy, Environment and Sustainability, Springer. This data I have taken. Then we can discuss, as I told you, there are different types of fuels. So first one is our biofuels. So it is from the natural gases found in plants and organic matter. We can say ethanol is the main biofuel used today. It is made from alcohol derived that is obtained from cooking and fermenting process of grain, usually corn. Most ethanol available is called E85, and this is a combination of 85% ethanol and 15% of gasoline. All Ford Taurus manufactured after 1998 are E85 compatible. So they are classified as bioliquid and biogas depending on the type of phases during extraction of fuel. Then there is ethanol and methanol. So alcohol type of fuel is alternative to petroleum-based fuel due to reduced greenhouse gas emission, toxic gas exhaust emission, and enhancement of overall energy efficiency. Moreover, they are convenient for IC engine, internal combustion engines, due to their high octane rating, burning velocities, and wider flammability limits also. In order to achieve better environmental sustainability, it is the right time to use lower molecular weight alcohols, which is alcohol processing lower molecular weight such as methanol, ethanol, and we can replacing other additives as octane booster in automotive fuels in the present situation. So this is the line diagram for ethanol production. Then hydrogen nowadays very emerging area. If anyone work in that area, definitely you can submit the project also. The government is also giving some fund in this hydrogen production, then application and storage. So in this, there are three major areas. In all the three areas, there are some challenges which we have to take care about that. The first one is our production. Then after production, the storage is also one of the major area. And the last one is our application part, that which we are using nowadays in the directly in the engine. So we have in engine which is related to hydrogen compatible. So hydrogen as an energy source of vehicle is still being developed, but is extremely promising also. It is the gas that can be created through electrolysis, the process of combining water and oxygen. So therefore, hydrogen is not only clean, it is also a renewable energy source. No fear of its depletion also. In a vehicle powered by hydrogen, we can say hydrogen fuel cells are contained in the vehicle and are replaced with hydrogen, just as gasoline is replaced into the tank of traditional vehicle. So consumer may even be able to fill up at home if an appliance that generates hydrogen is developed, so that it is small enough and safe enough to store in a garage also. So no distribution system currently exists for hydrogen as a vehicle fuel source. This is because hydrogen powered vehicles are not being marketed to consumer at this time. Then there is a natural gas. We can say this fossil fuel, it is considered to be an alternate fuel source because it is a preferably alternative to oil. We can say, why is natural gas considered to be an alternate fuel? Isn't gas a fossil fuel? So we can say natural gas is a fossil fuel, but it is different from gasoline or petroleum and coal because it does not contain the same harmful compounds found in other fossil fuels. Unlike gasoline, petroleum, and coal, natural gas has a negligible sulfur dioxide content, does not contain lead, has a low nitrogen dioxide content, a low particulate content, and a low carbon monoxide content. So as well, natural gas does not require carcinogenic additives to boost octane levels because natural gas is naturally high in octane. It is still abundantly available, which means that is practically to rely on its continued supply for hundreds of years into the future. With all these pluses, the natural gas is the natural choice for the abroad in the city New York. Natural gas has not been used very much, and as a result, abundant supply still exists. Not only in natural gas plentiful in supply, it is also a clean source of energy, and it is not renewable, which means that supply, although plentiful at this time, will eventually be depleted. That is why it is so important to develop other sources of alternative fuels also. Then last is our electricity. It is used to power a vehicle by an electric motor. The electricity is provided to the vehicle by batteries that store electricity. These batteries are recharged every day, normally in the evening hour when the vehicle is not being used. The owner of an electric vehicle must recharge the vehicle from home using a small recharging station, because nowadays we can see this recharging station in different places. Then this is propane. It is also known as LPG, liquefied petroleum gas, is a byproduct of process of natural gas and crude oil. It is widely used alternate fuel for cooking, heating, and vehicular application. It produces lower emission and burns cleaner than other fossil fuels. So this generation and its type: first generation, second generation, third, and fourth. So in the first generation biofuel, these are directly related to the biomass that is generally edible. You can see in the edible oil, the examples are corn, sugar, and animal fats. Biodiesel, corn, ethanol, sugar, alcohol. Then there is a second generation obtained from not food sources, non-edible source. We can say aquatic biomass for residues, abundant plant waste biomass, and agricultural waste. Second generation biofuels are defined as fuel produced from a wide array of different feedstock. Then generation third, in this related to algal biomass, but could not to a certain extent be linked to utilization of CO2 as a feedstock. So microalgae contains lipid and fatty acids over 30%. This biodiesel yields is more than a traditional crop. It can be easily grown in sewage and industrial pollutants. The end algal biomass is a good source of feed to animals. Then last one is our fourth generation, conversion of first, second, and third generation into carbon negative fuels. Fourth generation, you can see in this: pyrolysis, gasification, digestion, then fuel upgrading, gas cleaning, liquefaction, and then we can use this biohydrogen, biomethane synthesized biofuel, shipped in local uses and end user transport electricity. As we know, this biodiesel is a cleaning, burning alternate fuel for diesel engine. So it is oil from plants or animals used as an alternative to be blended with petroleum diesel in automobiles and industries fleets with diesel engine. The leading exporter of biodiesel is Argentina. The US creates its own biodiesel as well as around 1.1 billion gallons in 2015. And the requirement for diesel was added the renewable fuel standard in 2007. Grease or oil from cooking can also be converted to biodiesel and is more sustainable because it is byproduct of another process. So diesel engine can automatically run off blends with 20% or less biodiesel. Using more than 20% biodiesel or vegetable oil from cooking requires some infrastructure adjustment. Local and regional recycling centers have also been working to make biodiesel more accessible, but challenges in scalability hold biodiesel back, as well as corners over food prices if using raw material. So alternate fuel vehicles such as hybrids and electric car also displace demand for this biodiesel. So we are discussing this bioethanol is the most well-known biofuel and is an alcohol produced from corn, sorghum, potatoes, wheat, sugarcane, even cornstalk and vegetable waste also. It is commonly blended with gasoline. We can say plants grown specifically for any type of biofuel are not ideal due to the energy required, environmental impacts, and emission associated with harvest and transport. So ethanol is a complicated issue, but overall is helping ease demand of fossil fuel. The Brazil and this United States are the biggest exporter and consumer of this ethanol. We can see the advantages of this biodiesel. You can see in the first diagram, right hand side, if we are using B100, so the level of this emission is less than 40. So the emitted CO2 is used by plants to produce next phase crop. The energy balances is found to be 4.5:1. This correlates to the fact that more energy can be extracted from the product, biodiesel, than the energy consumed to produce the product. Then greenhouse gas emission, we can also see for gasoline is the maximum, then CNG and LPG is equal. Then if we use this diesel and ethanol 85%, that is also equal. Then the most favorable for our environmental condition, the B100 is the best at the point of greenhouse gas emission. Then this slide shows the only transterification process. This is well known, and you can see related to biodiesel paper. In each and every paper, this chemical reaction is there. So there is just a distillation. It is defined as a process in which non-edible oil is allowed to chemically react with alcohol. In this reaction, methanol and ethanol are the most commonly used alcohol because of their low cost and availability. This reaction has been widely used to reduce the viscosity. Mainly viscosity we are reducing for non-edible oil and for the conversion of triglycerin into ester. So this can be carried out into two ways: catalytic transterification and non-catalytic transterification. We can use this catalyst also, homogeneous catalyst and heterogeneous catalyst. So in this process, glyceride react with an alcohol, typically methanol or ethanol, in the presence of a catalyst, forming fatty acid, alkyl ester, and an alcohol. So homogeneous catalyst, we are generally using NaOH, KOH, CS3, we can say sodium hydroxide and potassium hydroxide. So these are the commercial application I have taken from these different sources. So in this, India's first biofuel powered flight that aims to reduce cost of air travel by replacing the costly aviation turbine fuel was successfully tested. This is 72-seater, the middle of the diagram, SpiceJet जो आप diagram देख रहे हैं, ये 72-seater SpiceJet aircraft, partially powered by biojet fuel, and it took off from Dehradun and landed at Delhi airport. So the duration of flight, it's not too much. It was only 25 minutes. Then I have taken this from one of my paper, this different properties which we see in this. There are 5 categories I have made. The first table you can see in this various edible biodiesel. The second one is our various non-edible biodiesel. Then animal fats oil biodiesel. Fourth one is our waste oil biodiesel. And the last one, various alcohol biodiesel, which is related to example butanol, ethanol, methanol, propanol, and pentanol. So in this paper or in this work, I have taken different types or different categories, we can say. The example for, suppose we talk about edible biodiesel, so coconut, palm, rapeseed, soybean, and sunflower. And then if we talk about non-edible, so cottonseed, jatropha, jojoba, karanja, and microalgae. So as I told in the previous talk also, if we are using any software, so before using that software, we have to validate. So this much of biodiesel I have not used experimentally. I have used this all numerical software, that is diesel RK. So different properties you can see like density, viscosity, calorific value, cetane number, flash point, carbon percentage, hydrogen, and oxygen, CHO. So I have taken this much of biodiesels for the study. In this calorific value, if we talk about, we know that it is the amount of energy released, or we can say produced, when 1 kg of fuel burns or any other substance is burned in the presence of oxygen, and the product of combustion are cool day of standard atmosphere conditions. Its unit is kilojoule per kg. Then cetane number, we know that it is an indicator of the combustion speed of diesel fuel and the compression needed for ignition. It plays a similar role of diesel as an octane rating, just for gasoline also. So cetane rating, also known as cetane number, and it is a measurement of the quantity or performance of the diesel fuel. The higher the number, the better the fuel burns within the engine of a vehicle. we can say in the other words, it is how minimized the delays between when the fuel is injected into the chamber and when the combustion begins. Then there is a flash point. We know that the lowest temperature at which a liquid will form a vapor in the air near its surface that will flash or briefly ignite on exposure to an open flame. The flash point is a general indication of the flammability or combustibility of a liquid. Then I have not mentioned here, there is one more property. This is our pour point. So it is a liquid is the temperature below which the liquid loses its flow characteristics. In crude oil, a higher pour point is generally associated with a high paraffin content, typically found in crude deriving from a larger proportion of plant material. So whenever we made a biodiesel, after that, there are some centrally instrument to check whether the that biodiesel is meet our requirement. We have to check before going to the experimentally or before going to the blended with the diesel. So there are some equipment like GCMS, then FTIR, then SEM images. You can see, as I told, I have taken not in this much of that. I think more than 25 biodiesels I have shown in these tables. There are 5 tables. I have categorized in different tables, but I have not used directly into the engine. I have taken this biodiesel and used in the numerical. But before numerical solution, I have validated in 2 ways. The first one, my experimental work, and I have taken my numerical work. And the second validation is I have taken one 10 years or 15 years back experimental work result and my numerical work. The boundary condition is same. Whatever they have taken the engine specification, the same specification I have taken in my numerical solution, and I have achieved the or we can say the errors between the validation part is less than 5%, which is very acceptable, and we can do the numerical part also. In the diesel RK, there is one software which is available in the internet. There is no need to purchase that software. So these are the some results and which I have used when I was in Manipur. So as I discussed, there are 3 major category in the biodiesel area. The first one is our production part. In the production, we have to, with the help of transferification and esterification process, we have to produce this biodiesel. Then there is the application part, which we have to use directly in our engine. As I told, less than 20% of blending we can use directly, but after that there is some challenges to modification of the engine. And before blending, there are some centralized equipment which is not having that facility in each and every institute, like GCMS, FTIR, and SEM images. So GCMS, what the GCMS will do. So gas chromatography and mass spectroscopy, it is extremely used for the analysis of these compounds, which include esters, or we can say fatty acids, alcohols, terpenes, aldehydes, and others also. It is also used to detect and measure contaminants from spoilage or adulteration, which may be helpful, which may be not harmful, and which is often controlled by governmental agencies, for example, pesticides. Then there is a FTIR, Fourier transform infrared spectroscopy, also known as FTIR analysis. It is an analytical technique used to identify organic, polymeric, and in some cases inorganic material. This analysis, FTIR analysis method, uses infrared light to scan test samples and observe chemical properties also. Then there is a SEM images also, scanning electron microscope. It scans a focused electron beam over a surface to create an images. The electron in the beam interact with the sample, and it producing various signals that can be used to obtain information about the surface topography and composition. So these are some results related to that particular paper, which was published in 2018 in ECM. Then after I have to, this is the line diagram of GCMS, identify the composition of the synthesized biofuel. Then this is the image of FTIR, which I have worked in this in the NIT Manipur, not in Bhopal. Then I'll discuss this research engine, which we have now in our institute. So in that major, in the next slide, I have shown this line diagram, which we are using if anyone wants to work in that area. So always this two diagram you have to include in your research paper. Like there are some parts, you can see the cylinder head, then crank angle, fuel injector, then flywheel. Flywheel is used in machines serve as a reservoir. We know that very well, which stores energy during the period when the supply of energy of is more than the requirement, and releases it during the period when the requirement of energy is more than the supply or demand. So in an automobile engine, the flywheel serves to smooth out the pulses of energy provided by the combustion in the cylinder and to provide energy for the compression stroke of the pistons. So the flywheel has three main functions. The first is to maintain a rotating mass inertia to assist the engine rotation and provide a more consistent delivering to torque during running. The second is to provide a ring geared for the starter motor to engage on. Then there is a crank angle encoder, airbox, and the dynamometer. Dynamometer is load device used to measure an engine torque and speed. We often measure fuel consumptions, emissions, and other parameters as well. The dynamometer can also be used to control the speed of the engine by varying the load placed on the engine. And engine dynamometer water flow proportion to the desired applied load creates resistance to the engine. A controlled water flow through the inlet manifold is directed at the center of the rotor in each absorption section. This water is then expelled to the other dynamometer body by centrifugal force. So this dynamometer places a load on the engine and measures the amount of power that the engine can produce against the load. And it also measures the torque also. Then there is a calorimeter, exhaust gas outlet, rotameter, load cell. There are some sensor like pressure and temperature. There are 6 temperature sensor and 4 pressure sensor are there. So calorimeter is used to measurement of heat carried by exhaust gases. It is a simple heat exchanger in which part of the heat of the exhaust gases is transferred to the circulating water. The hot gases are cooled by the water circulated in the calorimeter. So this is the line diagram. You can see the first one is CPU, then second is diesel fuel tank, third petrol fuel tank, fourth is throttle, then fifth is our petrol fuel pump, sixth is our dynamometer. Like that we have made. And if anyone submit the paper, so definitely this type of diagram you have to include in the paper. Then before discussing this, only there are 3 parameters or engine characteristic we can say. There are 3 major areas, that is performance, combustion, and emission. So for this results, I have used non-edible spirulina microalgae biodiesel. The experiment were carried out on a single cylinder 4-stroke diesel engine, and the objective of this work to identify the availability of microalgae biodiesel in diesel engines and fuel properties of microalgae biodiesel. At that time, best of my knowledge, the very less work have been carried out with different biofuel blends. But at the same time, there exists a lack of literature on utilization of microalgae spirulina with some other non-conventional fuel. So this biofuel are divided into 4 categories based on the production technology. Then this microalgae in the 3rd and vegetable soil in the 4th generation biodiesel are considered. According to the previous researcher, microalgae average biodiesel production can be 10 to 20 times higher than the other vegetables or seed soil. About 70% of energy across the world is consumed in transportation, industrial, domestic constraint, and only 30% energy represent for electricity consumption. So the research on the algae for the large scale production of biodiesel could be a better option for the future. So the algae production is almost everywhere, even on sewage or wastewater by industries and domestic subjects. So algae is a rich source of energy and oil, as well as provides very high yield per acre. So the composition of fatty acid methyl ester present in the spirulina biodiesel in the same with respect to entirely percentage of saturated and unsaturated fatty acid methyl ester. So the palmitic fatty acid methyl ester are maximum by 41.26%, and stearic and acid methyl ester is minimum by 0.98%. So as I told, there are three major areas in which we are more focusing when we are working on this diesel engine or research engine. Generally, the PG students or PhD students are working in that area. So the performance analysis parameter, like we are discussing specific fuel consumption, then brake thermal efficiency and exhaust gas temperature. I have not included all the results for the paper point of view. We can add if you increase the volume of work. So definitely you can add the production part, then the results related to GCMS, FTIR, SAM images. Then you can add the application part also, that is engine performance, combustion, and emission. And the last one, if still there is some chance, if you know the optimization techniques, any optimization technique you can apply. For suppose we can apply RSM, Taguchi, artificial neural network. So you can apply that also. So definitely the volume of work will increase. Nowadays it is very difficult if you send any paper in a good journal only for the engine characteristics. So it is very difficult to publish without adding some new novelty. So in this graph, there are three graphs I have added. I think the third one is this one. So the first one is our specific fuel consumption. It directly depends on the fuel properties like density, viscosity, and CV, calorific value of fuel, which plays an important role in incomplete combustion and fuel consumption. The number of fuel blended are tested, and it shows that the better performance of B20% blend ratio and slightly higher value of fuel consumption for different biodiesel. So the biodiesel has a higher viscosity, density, and lower calorific value. Results is an increase in fuel consumption of biodiesel. So the diagram shows this specific fuel consumption, different engine loading condition for different blend ratio. So B 0%, you can see in the diagram, it was found to be lower than the B100. Then the second diagram, brake thermal efficiency. It shows the variation of this BTE and the different engine loading condition for different blend ratio of fuel. The lower BTE, brake thermal efficiency, may be due to the lower volatility, the heating value of fuel, higher viscosity, the density of fuel, and we can say affected fuel formation processes during the combustion, which leads to smaller combustion process. So this BTE is found to be lower because of reduction in CV of fuel as the rate of fuel consumption increases as compared to diesel. So as according to the previous study also, it was concluded that optimum blend ratio, we can say B20%, would be the hyper importance as a long-term investigation. In this, the constant parameters like injection timing and compression ratio and RPM is 1500, injection timing is 23.5 degree, and compression ratio, which is fixed, 17.5. Then next one is our exhaust gas temperature. So again, in this, we can say the variation of average exhaust EGT. The average EGT temperature, we can say, increases with increases in the load of the engine when engine load increases. So the amount of fuel injected into the engine cylinder also increased. Thereby, more heat is produced by the engine. So the average exhaust gas temperature using biodiesel B100 is around 7.23%, lower diesel B 0%. So this EGT directly depends on the oxygen rate of the fuel due to the higher percentage of oxygen within the biodiesel as compared to diesel. So we can say early complete combustion is observed, although the biodiesel has much lower heating value. So the decrease in the exhaust gas temperature while using B100% is a good solution in the reduction of NOx formation from the engine. This is the values which I have already given in my paper also. Then the emission parameter, in this also I have, I think, shown 4 diagrams, not 5. The first one is our specific carbon dioxide emission, then NOx, then hydrocarbon emission, then carbon monoxide, then last one is our smoke opacity. So the first, this one, so then this exhaust gas emission parameters from the engine under test while using diesel and the micro algae biodiesel are different blend ratio which we have to use. So the first one, this carbon dioxide versus this different load. So the lower exhaust gas temperature is an indication of early combustion, and the lower heating value of using biofuels as alternative fuel places of fossil fuels. Thus, the before ignition allow higher time and crank angle for the complete extension working cycle. So the CO2 increases with fuel with biodiesel due to more time for converting CO2 when powering the engine with biodiesel. It is clear that there is an increase in the emission of CO2 from the engine at a higher blend ratio of this particular spirulina biodiesel. So this prediction value depicts that there is a partial combustion taking place in the engine chamber. When engine load increases, CO2 emission decreases, and the results of B20% blend ratio were found to be close to the diesel. So with the increase in the blend ratio of fuel, CO2 emission increases, which leads to better combustibility of the mixture. Then there is a NOx emission. The operating conditions are same. Then the NOx emission is dependent, we can say, on the temperature of engine cylinder. Compression ratio is the major parameter, and it shares the chemical elements such as oxygen content. Then we can say time is taken for the reaction to require place throughout the combustion also. So lower heat release rate is due to low temperature of combustion chamber. It results in a reduction of NOx emission. Then the nitrogen oxides and alternative poisonous gases are present in the IC engine. It is combustion chamber throughout the engine period, and NOx emission is reliant on the combustion chamber temperature and pressure. So even though the exhaust gas temperature was found to be lower while using microalgae biodiesel in place of diesel, the experiment predicts that NOx emission computed was lower than diesel in this particular compression ratio. We are talking about 17.5 compression ratio. So hence this CR 17.5 was, we can say, 6.8% lower NOx emission to be optimum B20 ratio in using microalgae spirulina biodiesel. Then hydrocarbon. So in this, the exhaust gas emission of hydrocarbon decreases with the increase in NOx emission. The biodiesel and its blend with diesel have show significant reduction in unburned hydrocarbon emission and an increase in NOx and NOx emission as compared to diesel. So even though the hydrocarbon emission was found to be lower while using microalgae biodiesel as compared to diesel, the experiments predicts that hydrocarbon emission computed was lower than the diesel in the compression ratio 17.5. Then carbon monoxide. So the CO emission produced within the combustion process due to incomplete combustion process in engine. The carbon monoxide emission lesser generated in biodiesel conversion of CO into CO2 due to a higher oxygen molecule present in the biodiesel chain, and thus reduced CO formation. So the CO emission decreased with increasing engine load. Due to the in that heterogeneous nature of diesel combustion process, there is a significant spreading of fuel air ratio inside the combustion chamber cylinder. The smoke emission decreases with higher content of oxygen in the biofuel, or we can say biodiesel, for contributing the complete combustion. The smoke variation versus different load using diesel and different blend ratio, we can say pure micro LV also, biodiesel as we can use, and the smoke emission, we can say the found by B20% is 12.35%. There is a smoke capacity. Then last is our combustion analysis parameter. In this, there is diagram cylinder pressure, cylinder peak pressure, cylinder heat release rate, and cylinder peak heat release rate, and then last maximum rate of pressure rise and ignition delay. So cylinder pressure analysis, we can say this, the crank angle variation concerning for two cylinder pressure information can be used to acquire combustion performance. It is observed from this graph, the cylinder pressure using Spirulina biodiesel at the corresponding crank angle was found to lie close to the result of B0%. Then even though it results in the high emission of NOx from the engine, initially the rate of combustion depends on cylinder peak pressure of CI engine, and further it is affected by fuel which is involved in pre-mixed combustion phases. The diesel and micro LV Spirulina depicts a variation of the cylinder peak pressure concerning the different engine loading at CR 17.5 ratio 1. Then there is a heat release rate, which is very important diagram for any paper. Without that, generally the reviewer are asking why you are not adding the heat release rate diagram. Even I am also asking when I review the paper. So within the combustion cylinder, amount of heat release in the premix combustion of a diesel engine depends on the ignition delay. And other parameters like rate of air fuel mixture and the heating value of the biofuels, or we can say fuel. So the heat release rate for standard diesel in higher blend oil, because of the blend ratio of fuel, which increases correspondingly with the decrease in the viscosity of the oil and thus improve spray formation rate. So HRR affected by air entrainment and lower air fuel mixing rate and effect of viscosity of fuel decreases with increased blend ratio and oxygen content percentage, which is higher when compared to standard diesel. Then maximum rate of pressure rise. So the pressure in the first interval rising reaches a higher value of combustion pressure called peak pressure, and the second interval of time is reduced with a variation of crank angle during the defined period of working cycle. The fact of cylinder peak pressure occurs near the top dead center and hence increases the power output of the engine. So determining the knocking tendency and the higher level of NOx emission directly depends on a maximum rate of pressure rise within the combustion cylinder of an IC engine. So this variation of maximum rate of pressure rise, the significantly lower rate of pressure rise is obtained at 8.15 degree bar per degree. And we can say it can be noted that the same compression ratio used of B100% proves to have better anti-knock features. And then last is our the ignition delay is the time difference measured in the crank angle between the start of fuel injection timing and the start of fuel ignition. So the higher ignition delay due to more fuel to be burned in the premixed combustion phase, the higher ignition delay leads to higher air fuel rate, thermal efficiency, and maximum heat release rate of the engine. So the higher delay of Spirulina biodiesel blended fuel indicate a leaner air fuel mixture, which leads to a reduction in combustion temperature and NOx emission. So an increase in the pressure and temperature of the compressed air to the engine. So this might stabilize the engine is maintaining reasonable temperature and pressure while producing a smaller amount of emission. As I told, I have not included all the results in this slides. So the conclusion is the general conclusion, this slides, and the second one conclusion is related to my work. So general conclusion is the alternate source of energy are eco-friendly and less harmful to the environment as compared to conventional fuel. The level of air pollution may also be reduced while we are using this alternate fuel. The present scenario of global warming can also be reduced by using alternate energy resources. Then since these alternate energy sources are renewable in nature, they can be used extensively without much affect the environment. And then these steps can help in conserving natural resources also. Then, as I told, I have taken this one of my paper published in energy. So these are the conclusion. Microalgae biodiesel has been used in alternative fuel in place of diesel. Since there is a decrease in the phase-to-phase variation of biodiesel, then combustion processes increase due to higher cetane number and oxygen content %. In all the blend ratio of microalgae spirulina biodiesel, ignition delay is shortest in diesel, which is due to cetane number. Then by increasing the percentage of spirulina biodiesel, brake thermal efficiency reduces, and there is a marginal increase in specific fuel consumption. And then this peak pressure was observed as 86.0 bar. There are some values. Then last is the peak heat release rates value was observed, this one. And we are using this for diesel and microalgae biodiesel. Then there are some references which I have used to make this PPT. Thank you for the patience. If any query and any doubts, then you can ask me, or you can drop a message, or for any
thank you, sir, for a wonderful presentation
related to how we can prepare the research article, which general is suited for your related to that particular area. I'm talking about biodiesel. So you can submit your article in fuel, energy conversion and management, energy, journal of cleaner production, journal of hydrogen energy. Then in Springer, you can submit in ESPR. There are a lot of journals. You just mention, or before submitting, you just check the volume of work also it is required, and how you are presenting your work and how you write, that is also important, because a lot of paper was rejected due to only the presentation skill or writing skill also. Nowadays the paper was rejected from the editor desk only. They are not submitting, or they are not further process के लिए भी वो नहीं भेज रहे हैं. For suppose if you want for review process also, they are not sent to for review also. So be careful about that when we are submitting the paper.
So any question from participant side?
thank you, sir, for a wonderful presentation.
Any question?
Yes, sir.
Yes,
sir, you mentioned regarding properties of biodiesel, some free software is there. Can you tell me the name of the software, sir?
Diesel RK. Just write diesel in caps lock RK.
Pardon, sir. If possible, can you type in chat box, sir?
Diesel RK, diesel, DIESEL,
Diesel RK.
diesel RK.
Or you can,
okay, sir. Okay.
Or you can just go to in Google Scholar. You can see lot of my paper, around more than 10 to 20 papers, which my scholars, with the help of my scholars, they have published. You can see the more information also related to this diesel RK. What are the different equations they are used? What are the boundary conditions they are used? Before, as I told, before using that software, before going to that software, first validate your work. After, you can use your any type of which you have in your system, in your institute or your nearby institute. You can use that software also. It is easily available also. There is no fees or there is no institutional charge also, no need to purchase that software, because very difficult to purchase each and every biodiesel, or we can, there is very difficult to produce also. So my candidate was also working, presently also working for this diesel RK. If you have any another doubt also, then you can contact me by mail, or my contact number you can write if you want, then you can contact me anytime related to that particular software.
Thank you so much, sir. Sir, is there any, what are the any other extra uses for this software, sir? I mean, what type of works you can use for this software?
See, there are some equations which we have to know. This are the basic equations, like conservation of mass and others, combustion equations. If you don't know that equations also, no need to worry about that. You just follow, and there are some study material also that in that software. You just read, and as I told before going to that software, first we have to validate. There are two types of validation. The first validation, if you are using diesel fuel only, that diesel fuel results and the same configuration of engine, or we can say the specification of engine, you have to use in the diesel RK, and the properties of that particular biodiesel or diesel, you have to mention that property also in the software, and you can achieve. There is the results will come in the Excel form. After that, you can use the any plotting software, not Microsoft Excel, or no need to draw a diagram in that particular software. You can use TechPlot or Origin. That one is better option for nowadays. So you can use Origin and TechPlot, then you can plot the result. This jitna bhi result, the results shown in the PPT, the students are making in the TechPlot or Origin software.
Thank you, sir. One more doubt, sir. While preparing biodiesel, like raw oil, can we, I mean, is there any challenges? Like
No, for this chemical people will do very easily. For us, it will take hardly 1 week to learn the process of this transferification or esterification. It's not a big deal. You can make in your own lab also.
my doubt
Very
is,
little.
sir, can we get directly like raw oil? Can we get directly, or you have to add any chemical, sir, to get the raw oil?
Raw oil means
So,
this
for
biodiesel, no?
example, some of our students are extract before producing biodiesel. You need raw oil, means raw oil, na, sir. Based on the oil, for example, our students used some palmyra tree. They extracted palmyra fruits, and they go to the mill, like coconut tree. They use the palmyra tree, sir. But they was unable to get the oil. They get some powder. So is there any other process to get the oil?
Abhishek sir.
Sir, sorry to interrupt you. You are not getting like whatever oils we use in our day-to-day life also, na. For cooking, we use mustard oil. That is generally written. That one is virgin oil or virgin oil or raw oil, like that. And by using that oil, we produce biodiesel.
Okay, sir.
For biodiesel, we need two things: this oil, alcohol, and catalyst. Catalyst is used to make a fast reaction between this oil and alcohol. So that is only raw oil that we usually call raw oil.
Okay, sir.
Okay.
Sir, one more last doubt, sir. Sir, for example, if you want to, for example, if you are using nanoparticles in the biodiesel doping. So while testing some or EDX analysis, you have to test the only nanoparticle, or you have to test the combination of nanoparticle with biodiesel, sir, for some analysis. Got it, sir?
What
Can
you
you
ask?
repeat? While preparing, while testing the SEM analysis, for example, we are using nanoparticle in our biodiesel. We doped the nanoparticle in our biodiesel, sir, for example. So while testing SEM analysis, you have to test only nanoparticle or Sir, you have to test the nanoparticle along with the biodiesel sample. For some analysis.
Sir, you are adding, yes, you are adding nanoparticle in biodiesel, and that blend you are going to use in the engine. So just alone to find the characterization of nanoparticle is no use. You need to do all this analysis while means whatever blends you are preparing, that one.
So along with nanoparticle, you have to use the biodiesel mixture, right,
Sir,
sir?
but for nanoparticle, not we will do same analysis. We will do its stability is prepared like that.
Okay, sir. Thank you, sir. Thank you.
Yes, sir. Any more
Thank you so much,
questions?
sir. Sir, please share
Mr.
the
Abdul?
PPT.
Yes, yes. Abdul जी, आप कुछ पूछ रहे थे? माइक ऑन कीजिए, आपका माइक ऑफ है, माइक ऑफ है, माइक माइक
हाँ मिल गया सर मुझे. I got that. Thank you, sir. Thank you.
So any more question? So I am very much thankful to Dr. Tikendra Nath Verma
Sir, I have a
for
question.
Sir, good evening.
Sir, I have a question.
yes, one by one.
Okay. Hello, sir.
yes,
This is
okay.
Dr. Bisma Malik. I'm from
Yes.
Jammu and Kashmir. So I'm working as an assistant
Yes.
professor, and before joining the government sector here, I'm working in Chandigarh University for more than 3 years in the research and development.
Okay. Okay.
Thank you so much, firstly, sir, for the great presentation, because I have worked somewhere in biofuels. I have
Yes,
used
I
this
have not presented actually. Dr. Tikendra, are you here? Dr. Tikendra?
Dr. Nath, my question is to Dr. Nath.
Yes,
The
yes, ma'am.
speaker.
Tell me.
Yes. Yes.
So, sir, actually, I'm working in that very phase on Trichoderma ricci for evaluating this ethanol production. Sir, my question is there is any commercialization of this biodiesel till date in India? There are cars who run on these biodiesels, or the formation, the manufacture of this biodiesel is only in the labs till date. As I have seen nowadays, many research labs are working on these biodiesels, this biofuel, using plant materials, using many microbes as well nowadays. But if there is any commercialization or there is any practical experiment, that in India there are cars who run on these biofuels, as we have examples like in Japan, they have their cars who they run that cars on biofuels. Is we have in India that cars run on biofuels? Is there that application of biodiesel till date is having some literature background?
Okay, Malik madam, you are asking why we are not using still this biodiesels in our practically in our day-to-day life or our Indian roads. So the problem is, if we take any edible, non-edible, or any type of biodiesel, so the problem is the first problem which I facing the production. The mass production is required for this diesel engine or for whatever we are using in our day-to-day life. So the main problem, just we are using different type of biodiesels for research and development process. What are the different parameters which we have seen in the performance, combustion, and emission? But in practically, you are telling correct 100%. We are not using in our day-to-day life for the research purpose or for our PhD producing or MTech producing. We are using this area. For practically nowadays, no one is using for this biodiesels, or now in our institute in MANIT Bhopal also the students are not allowed to use the two-wheelers or four-wheelers. Our director is already started the electric vehicle in our institute. There are 4 buses throughout the day or night. It will work. It is continuous running. But biodiesel is not used in our institute also for, or we can say it is practical. The problem is that the mass production is required. So
Sir,
that's the main issue.
actually, sir, I will add a point that nowadays we are not using the edible or the non-edible, but we are nowadays focusing on the waste material for the
Correct,
production
correct,
of the biofuel, so
correct,
that there should be no, a junk of the pressure on the agriculture crops.
correct, madam.
We are actually facing the population explosion. We are
Correct,
actually
madam.
facing the situations like shrinking of agriculture lands. That's why nowadays people are thinking of production of biofuel from the waste material.
Correct, madam. You are telling correct.
If we take one example of the paddy fields from the paddy plants, we take the rice, we take the wheat, and the rest we can use for the biofuel production. So there is, there is no pressure on the agriculture land and the agriculture plants or the food crops. So I think that every then and now people are saying that we have increased the biofuel production by this, bioethanol production by this, but at the end of the day, until and unless all these comes not into practical applications, I guess that experimentation that remains in the labs. It will not come to the use for the use of the common people. Actually, the thing is that practically,
Madam,
Uh,
just I would like to add to your point. Basically, due to these concerns only, government has come up with the revised biofuel policy in 2018. So, considering these issues only, government is revamping or revising the targets of ethanol blending. Basically, they are not targeting on biodiesel blending anymore, as far as our country is concerned.
Right,
We are
sir.
now-
I know it, that they were actually now interested in blending ethanol with something else.
Yes.
So
Yeah.
that we
And
get
that too-
we get
that
use
too
the
with-
bioethanol as compared to biodiesel
Exactly.
or
Yeah.
anything else.
And one more thing is there, even just now when in the last year when we revamped the production of ethanol, then there was impact on the prices of sugar. So these are certain other issues which are basically paralyzing the efforts of government on targeting agri crops for producing of be it ethanol or biodiesel. These are also certain important areas. That's why the government has now started focusing on hydrogen.
Correct, sir. That's why I'm actually telling that now research labs are also focusing on the waste materials, so that we will not having any pressure on any type of the plant or
Agri
the
supply chain. Yeah, very true.
Correct, sir.
So,
Sir,
madam, one more thing I would like to add.
Sir, Abhishek, sir,
Am I
can
audible?
Yes. Sir,
Yes,
Abhishek,
yes.
sir. Can I speak, sir, a few minutes?
Yes, yes.
I'm Sridhar Ram.
Yes, sure.
Sir,
Yes.
Madam is asking about commercialization of the biodiesel. I worked in the Indian Institute of Chemical Technology, Hyderabad, in 2003 on biodiesel production. In Hyderabad, Southern Biotechnologies established a plant on biodiesel production. They produced biodiesel and tested on few RTC buses and few autos and a few vehicles. But after 1 year, all these vehicles faced a problem, a carbon deposit problem and starting problem. There are a lot of problems with this biodiesel, but the biodiesel production is very nice on paper. But reality, biodiesel is not possible commercially.
That is why, sir, I pose this question, that production of
that
bioethanol,
is
either biodiesel, is in the labs. No practical
It is only
application
lab.
till date is possible.
But biodiesel is that is forming a gum-like material because of oxidation.
all those-
That is produced from Jatropha. It is produced from Jatropha, but it is forming a gum-like material. Just like if you use
Basically, injector fouling takes place, and even deposition takes place in the cylinder liner also.
yes,
Due to this.
there are so many problems.
Sir,
Biodiesel may
actually-
not become a successful fuel in future. But now government is selling E20 petrol, E30 petrol. That is means ethyl alcohol 20% and 80% is petrol. Like this, now government is encouraging e-petrol, but it has cost is very high. In Telangana, government to encourage e-petrol, they established ethyl alcohol plants from corn oil, but local people are opposing to establishing these ethyl alcohol plants because it causes a lot of water pollution. There are challenges to set up ethyl alcohol production plants. A lot of environmental problems are there. So the villagers are not accepting to establish these ethyl alcohol plants in our Telangana particularly. So it happened in all places. So according to my knowledge, the best fuel in the future is green hydrogen. That Modi, our respectable Prime Minister Modi is also focusing on green hydrogen. And hydrogen, there are two again, gray hydrogen, blue hydrogen. But green hydrogen is a perfect hydrogen which can be synthesized from water, electrolyzed from water by solar and wind energy. So we are thinking about EV vehicles. Electronic vehicles are not environmental friendly. They are clean energy resources. Strictly speaking, lithium-ion batteries mining cause a lot of environmental destruction. They are clean. They are not green. So there is a difference between clean energy resources and green energy resources. But in your title, you are mentioned clean energy. Clean. It's not clean is the right word. Green is the right word. Green is 100% environmental friendly. Clean is air pollution point of view. They are environment friendly, but the manufacturing causes a lot of environmental destruction. So as of information available now, the green hydrogen is going to be a future fuel for India. It can solve a lot of problems to our India, particularly in the field of renewable resources. That I can say in this conference. Sir.
Yes.
Yes.
Let me add 2-3 points, madam. Even government of India has proposed and they have aimed to add ethanol and biodiesel also. If you will see your scooty or Activa or anything, there it is written E20. So nowadays already whatever petrols we are getting from the petrol bunk, 10% ethanol is blended in those petrol. And also for biodiesel, whatever problems associated, we all have discussed. So that was from olden times. Now there are many things are available. We are editing. We are having antioxidants for improving their life, that oxidation stability. And there are different centers are there. Even those who are in Punjab, they may know the national. Its name is in Jalandhar, Kapurthala, National Biofuel Research. Some institute name is there. Just they have changed 2 years back only. I have visited, so they are doing very wonderful research in the area of biofuels also. And also in previous presentation also, we have seen that batteries, means these EVs, whatever electricity we are means for running the electric vehicles, we need electricity, and for generation of those electricity, we need to spend the coal, then the mines. So whatever emissions are coming, that are more than even from petrol or diesel vehicle. So that's why EV yes, and in previous presentations also, speakers have discussed that now we are not thinking, but after 5 or 7 years, Madhu Mohan from industry, he has told that after 5 and 6 years, when we will see that different solar panels, these are not that much effective. So in Uttarakhand, those who are in Uttarakhand, they can search that video in YouTube. That is also available. There is 1,000-ton plant ethanol production, and they are using those agricultural waste material for producing ethanol. So there are different pro and cons is there with all available sources. But definitely biomass and biofuels are a very good option, because whatever emissions will be generated after this one, so those emissions, CO2 emissions, primarily the greenhouse gases, so that will be absorbed during the photosynthesis process of that biomass. And that's why microalgae is more preferred, because it was observed that microalgae absorbs more amount of carbon dioxide. So all those things are there. So, yes. So definitely after this FDP, we will share our profile, and we all will be in together. So now it is time to end this session, and validity session is there. So please be in this meeting. After validity session, I will discuss something about test. Now we are having our respected principal, sir, Dr. Sanjay Kumar Singh, Professor Sanjay Kumar Singh, sir. So I would like to invite our principal sir to speak the success of this event. Dr. Murli.
Thank you, Dr. Abhishek Sharma ji.
Thank you, sir.
And good evening to all of you. It is with immense pride and deep sense of gratitude that I stand before you today to mark the successful conclusion of this faculty development program on clean energy and environmental sustainability, organized under the AICT and hosted by our Department of Mechanical Engineering at Government Engineering College, Palamu. I extend my heartfelt thanks to AICT New Delhi and ATAL Academy for sponsoring this significant program, which is a testament to the commitment of academic institutions in India towards addressing critical global challenges like climate change, environmental degradation, and energy sustainability. Over the past 6 days, this program has brought together some of the brightest minds, faculty members, researchers, and also industry experts to discuss, deliberate, and exchange ideas on clean energy solutions and sustainable environmental practices. The range of topics covered, including renewable energy technologies, alternative fuels, solar energy systems, climate change mitigation, and waste to energy innovations, have really given participants a comprehensive understanding of how to address one of the greatest challenges of our time. I am particularly grateful to our distinguished resource persons who shared their vast expertise and insights, enriching the knowledge of every participant. Their sessions not only inspired innovative thinking, but also encouraged practical applications of sustainable practices in various domains. To our participants, I commend your enthusiasm and dedication. Despite the rigor of academic and professional commitments, you actively engage in every session, demonstrating your unwavering commitment to advancing knowledge in this vital field. The skills and insights you have gained during the FDP will undoubtedly help in your teaching, research, and efforts towards sustainable development. I would like to acknowledge the tireless efforts of the organizing committee of Government Engineering College Palamu, especially Department of Mechanical Engineering, led by Dr. Abhishek Sharma, Program Coordinator, and Dr. Murli Manohar, Co-Coordinator of this program. Your meticulous planning and execution ensured the seamless conduct of this FDP. The success of this ATAL FDP is a reflection of your hard work and dedication. As we move forward, let us take the learnings from this FDP and strive to incorporate them into our respective roles, be it in academia, research, or in industry. Clean energy and environmental sustainability are not just concepts, they are necessity for the survival and progress of our society. Let us all commit to becoming ambassadors of sustainable development and contribute meaningfully to the achievement of the United Nations Sustainable Development Goals. In conclusion, I would like to thank each one of you for making this ATAL FDP a resounding success. Let this not be the end, but the beginning of a collaborative journey towards a cleaner, greener, and more sustainable future. Thank you all, and I wish you all the very best in your endeavors. Jai Hind.
Thank you, sir, for your inspiring word. So, Dr. Murli.
Yes, sir. Yes, sir. I'm here, sir.
I would like to invite Dr. Murli for giving vote of thanks. My co-coordinator, Dr. Murli from Electrical Department.
Thank you, sir. Respected principal, sir, esteemed resource person, distinguished participants, colleagues, and friends. Good evening to everyone. It is my privilege to honor to deliver the vote of thanks on this momentous occasions as we conclude the ATAL Faculty Development Program on clean energy and environmental sustainability. First and foremost, I extend my deepest gratitude to our chief patron, Professor Sanjay Kumar Singh, Principal of Government Engineering College, Palamu, for his inspiring leadership, constant encouragement, and unwavering support in making this program a grand success. I am extremely grateful to the AICTE Training and Learning Academy for sponsoring this impactful initiative, which has provided a platform for knowledge sharing and capacity building in the critical area of clean energy and environmental sustainability. My heartfelt thanks goes to our distinguished resource persons who have graced this program with their presence and expertise. Your insightful session have not only enlightened our participants, but have also empowered them to contribute meaningfully to the challenge of energy sustainability and climate change. To our participants, I express my sincere appreciations for your active involvement throughout this program. Your thoughtful questions, discussion, and contribution have added great value to the sessions and reaffirmed the importance of such collaborative learning. I would like to thank my colleague and program coordinator, Dr. Abhishek Sharma sir, for his momentous, meticulous planning, guidance, and efforts in organizing this FDP. Working with you has been a enriching experience, and your dedication is truly recommendable. A special note of gratitude to the Department of Mechanical Engineering as well as the supporting staff of Government Engineering College, Palamu, for ensuring this seamless execution of this program. Your hard work behind the scenes has been instrumental in this success. Last but not least, I thank the Department of Higher and Technical Education, Government of Jharkhand, for their continuous support in promoting quality education and fostering research and innovation in our institute. As we conclude this program, let us take forward the valuable learning, idea, and collaboration cultivated over these 6 days. May they inspire us to strive for a cleaner, greener, and more sustainable future. Thank you all once again for your contribution. I wish you all very best for your future endeavors. Jai Hind.
Thank you, Dr. Murli. And I am thankful from bottom of my heart to all the esteemed speakers, our respected principal sir, my co-coordinator, Dr. Murli, all the participants. So I hope this wonderful, FDP was very informative and wonderful. And it is my humble request that whatever we have learned from all this in coming last 6 days, we must apply in our home also. We must try to utilize less amount of, means we must not waste the energy either in the terms of light or in vehicle or like that. So I request that we must follow all those things in our day-to-day life also. Test will be from 9:30 to 10:30. So I will stop the recording, and I request other faculty members also, those who are going to appear in the test, if they are comfortable about the procedure, then no problem. Otherwise, one demo I can show you that how you need to appear in the test. Dr. Murli, I'm stopping the
Yes, sir. Yes, sir. Recording.
Yes.
Yeah.
Dear participants, now